get this right. OpenAI, they just released this research paper. And let me tell you, it has the whole AI community kind of freaking out.
And for good reason. It's basically saying AI might be able to do the work of like actual machine learning engineers and like really well.
Okay, so we've all seen the headlines, right? AI playing chess like a boss, writing poems, even composing music. But actually building other AI systems, that feels, I don't know, different somehow, more.
Right, exactly. It's like next level stuff. So basically this paper introduces this thing called MLE-Bench. It's like a benchmark, a test to see how well these AI agents can actually perform like real machine learning engineering tasks. They basically gave these AI agents 75 different Kaggle competitions and said, go nuts.
Kaggle, and I'm sure some of our listeners know this, but it's where all the data science wizards go head to head. They build algorithms, compete. It's intense.
Absolutely. And we're not talking about, beginner level stuff here. These were real deal Kaggle competitions. Natural language processing, computer vision, even signal processing, like really complex stuff.
So, hold on, let me get this straight. The AI was given data and then had to basically do everything a human would, like clean the data, build the model, debug it, all of it, without any help.
Pretty much, yeah. They had to analyze the data, come up with a model, debug it if it went haywire, and then submit their results.
Right.
And get this, OpenAI actually had to create completely new test sets for a bunch of these competitions.
New test sets. Okay, for those of us who didn't sign up for AI 101, can you break that down a bit?
Sure. Think of it like this. Imagine you're training for like a marathon, right? You wouldn't run the entire marathon every single day while you're training. You'd run different parts of it. You'd save the whole shebang for race day.
Okay, makes sense.
Yeah, so it's the same with training AI. You split the data, have some for training the AI and some for testing it to see how well it performs on data it's never seen before. That's the test set.
So OpenAI had to make these new test sets because the original Kaggle ones were, what, top secret? They didn't want the AI to have the answers beforehand?
Exactly. And to really put these AI agents through the ringer, they used the private leaderboard scores from Kaggle to see how they stacked up.
Private leaderboard, is that like the VIP section of the data science world or something?
Kind of, yeah. It's like this. During a Kaggle competition, everyone can see the public leaderboard. It gives you an idea of how you're doing, but the real deal, the one that really matters, is the private leaderboard.
Yeah.
It's based on data that's hidden, like super secret data, and it's only revealed at the very end of the competition.
So you don't know how well you really did until the very end. That's kind of intense.
It is. And it actually prevents this thing called overfitting, which is where a model might look like it's doing great because it's memorized the data it's seen, but then when it gets thrown a curveball with new data, it just falls apart.
It's like acing a practice test because you memorized all the answers, but then you completely bomb the real thing.
Exactly. So by using the private leaderboard, OpenAI made sure they were getting an accurate picture of what these AI agents could really do.
So cut to the chase. How'd the AI do? Did it win any of those like super prestigious Kaggle medals?
Oh, they did more than just win a few. It's
Yeah?
actually pretty amazing. OpenAI had a few different AI models in the running, but the one that really stole the show was their latest and greatest. And they paired it with this AI agent framework called AID.
Aid.
Yeah, it stands for AI-driven exploration. Think of it like the conductor of an orchestra. But instead of musicians, it's guiding the actions of the AI during the competition. So get this. OpenAI's model, working with AID, managed to snag a medal in almost 17% of the Kaggle competitions.
Wow, 17%. I mean, winning even one Kaggle competition is a big deal, right? Like, how does that stack up against actual human competitors, the ones with, years of experience?
Right, and it's not just about winning once, it's about consistency.
Yeah.
This AI model averaged seven gold medals on MLE-Bench. And to become a Kaggle Grandmaster, a human needs 5.
7 gold medals? That's like walking into a room full of professional data scientists, some of the best in the world, and just cleaning up competition after competition. That's insane.
It is pretty wild, and it makes you wonder how it's actually approaching these challenges, right? Like, is it thinking like a human data scientist, testing things out, learning as it goes?
Yeah, because it can't just be brute forcing its way through. There's got to be more to it than that, right?
You would think, right? And that's something researchers are trying to figure out. But one thing they did find is that giving these AI agents more chances, more attempts at a competition, actually made them way more likely to win a medal.
So more tries, better results, kind of like how humans learn, actually. The more you practice something, the better you get at it.
Exactly. And it might sound obvious, but it suggests that there's more to how these AI agents are doing what they're doing than than just raw processing power. They seem to actually be learning from their mistakes and getting better over time.
Okay, that's kind of reassuring, honestly. It means it's not just about having the biggest, baddest computer. There's actual learning happening.
Right, exactly. And what's even more interesting is that giving them more processing power, like more GPUs, didn't actually make a huge difference in the results.
Now, that's weird. You'd think more power, better performance. What's the deal with that?
That's the million-dollar question. It seems like there's something else going on, something we don't fully understand yet. Maybe it's about how effectively these AI agents are actually using the resources they have.
It's like giving someone a Ferrari and they don't know how to drive stick. So we've got these AI agents entering data science competitions, winning gold medals left and right, and even learning from their mistakes. But here's the big question. How do we know they're not just like spitting out old solutions? How do we know they're not cheating? It's something OpenAI took very seriously.
They did, and they called it the contamination conundrum. How to be absolutely sure that these AI agents weren't just regurgitating solutions they'd seen before.
So how did they rule that out? How did OpenAI make sure everything was, by the book?
Well, they really dug deep into how familiar these AI models were with solutions from previous Kaggle competitions. Imagine it like trying to figure out if a student had secretly peeked at the answer key before taking a test.
Right, because if the AI had already seen the answers during its training, the whole thing would be pointless. So what did they find? Did they catch the AI red-handed?
Surprisingly, no. They found absolutely no connection between how well an AI did on a competition and how familiar it was with the solutions. It wasn't just memorizing and regurgitating, something else was going on.
Okay, so it wasn't cheating in the traditional sense, but could it be picking up on other clues, like recognizing specific challenges based on how they're described, and then using that to its advantage?
That's a really good point, and that's something OpenAI wanted to make sure of. So they actually messed with the competition descriptions, making them kind of like scrambled and confusing, much harder to recognize.
So it was like giving the AI a puzzle where all the pieces were mixed up, maybe even some pieces missing, and seeing if it could still solve it.
Exactly. And get this, scrambling those descriptions didn't really change how well the AI did.
So it wasn't just relying on recognizing keywords or phrases in the problem description. It was actually doing something
Mhm.
more. And that's both exciting and kind of unsettling, don't you think?
I know, right? It kind of challenges what we thought we knew about how AI learns and solves problems. It seems like there's something deeper going on here, something beyond simple memorization.
Okay, so we've established it's not cheating, at least not how we typically think about it. But if it's not just memorizing, then what is it doing? How is it learning and adapting like this?
Yeah, it's a huge question, right? Like, if AI can do this, if it can actually compete and win in these competitions, what does that even mean for people, for machine learning engineers? What's going to happen to their jobs? It's not an easy question to answer.
Yeah, it's not as simple as like robots are taking over, but it does make you think like what skills are going to be important in the future? If AI can do all this technical stuff, what does that mean for us? What do you think?
Well, one thing this research really hints at is like the potential for AI to just totally turbocharge scientific progress, right?
Hmm.
Imagine AI working side by side with researchers, like in healthcare or climate science, just crunching through massive amounts of data, finding patterns we could never even dream of spotting, and then helping to develop solutions way faster than we ever could on our own.
It'd be like having a team of like super powered research assistants working 24/7, never getting tired, never needing coffee breaks.
Totally. But, and I think this is super important to remember, there's always another side of the coin, right? With any new technology, especially something this powerful, we have to be super careful about how it's used. We have to make sure it's being used ethically, responsibly. That's a conversation we need to be having right now, not later, not when it's too late.
Totally agree. It's like we have this incredible opportunity to shape the future, to make sure AI is a force for good in the world. It's up to us to get it right.
100%. And that kind of brings us back to this research, right? As mind-blowing as it is, we have to remember this is still early days. We're just starting to scratch the surface of what these AI agents can do, how they learn. It's like we've stumbled into this whole unexplored continent, and we're just starting to map it out.
Okay, so we've talked about the what AI playing in the big leagues of data science, but what about the how? How are they actually doing this? We touched on it earlier, but I'm kind of hoping we can, go a little deeper here. What's the secret sauce? What's going on inside these AI agents that lets them pull this off?
Oh man, I wish I had a simple answer for that. That's the million-dollar question, right? It's like trying to figure out the inner workings of like some super complex machine.
Yeah.
But we are starting to get some clues, and it's pretty exciting stuff. Remember how we talked about giving the AI multiple tries at a competition, how that seemed to make them better?
Yeah, the more practice, the better the performance.
Right. Well, that suggests that there's more going on than just memorizing answers, right? It's like they're learning strategies, figuring out how to adapt to new situations, kind of like how a human data scientist would over time.
So they're developing like a data scientist's intuition just from practicing and experimenting. That's kind of wild.
It is wild.
Yeah.
And it really points to a level of learning and adaptation that, honestly, we haven't really seen in AI before. But, and I want to be careful here, we can't say for sure that this is like true understanding or consciousness or anything like that. It's still early days, and we have to be cautious about how we interpret these results.
Right. We don't want to jump to conclusions about AI suddenly becoming sentient or anything like that. It's important to remember that at the end of the day, we're still talking about algorithms and data, not, conscious thought or whatever.
Exactly. But even without going down that rabbit hole, the fact that these AI agents can compete and often win in areas that we once thought were exclusive to humans, well, that's still a really big deal.
No doubt about it. So it's not just one AI model that's really good at this, right? OpenAI's model, the one with aid, that was the
Yeah.
start of the show. But you said they tested others too, right?
Oh, yeah, for sure. And while the one with aid was the top performer, some of the others weren't too far behind, like GPT-4, for example. If you give it enough time to work on a problem, it can achieve some pretty incredible things, too. One, its fair share of medals.
So it seems like processing time, like actually giving the AI enough time to think things through, that plays a role too, not just the algorithm itself.
Definitely. And another thing they found that was interesting was that the type of task really mattered. If you give the AI a very structured problem, something with a well-defined solution, like something a human machine learning engineer could probably knock out in a few hours, the AI just crushed it.
So basically, if you give it a clear set of instructions and a well-defined goal, the AI is in its element. It's like, okay, AI, here's a recipe. Now go bake me a cake. And it bakes an amazing cake, follows the recipe perfectly.
Perfect analogy. But where things got more difficult, where the AI really seemed to struggle, was with the more open-ended challenges, the ones that required more creativity, more out-of-the-box thinking, like debugging really complex code or understanding really subtle patterns in the data, things like that. That's where the limitations became really clear.
So if you ask the AI to invent a new kind of cake, something no one's ever even thought of before, that's when things get tricky.
Exactly. Those tasks, the ones that require human ingenuity, adaptability, that ability to think critically and connect the dots in unexpected ways, those are still really hard for AI.
So it's like we've got these super skilled, but maybe a little inflexible digital workers, amazing at what they're trained for, but not so good with the curveballs.
That's a great way to put it. And it really highlights how important human oversight is going to be in all of this. As AI gets better at these technical tasks, it frees us up to focus on the things that humans are really good at, the creativity, the critical thinking, the big picture stuff.
Right. It's about finding that balance, that collaboration between humans and AI, not one replacing the other.
Absolutely.
Yeah.
So to bring it back to that original question, can AI do machine learning autonomously?
hmm
Based on what we've seen in this research, the answer seems to be, well, kind of. It's complicated.
Not a simple yes or no. There's a lot of nuance here.
Exactly. It can definitely do some pretty amazing things, stuff that rivals human experts. But it's not about to replace us entirely just yet. The real magic, I think, is going to come from finding ways for humans and AI to work together to complement each other's strengths.
I like that. We've gone from like fearing AI taking our jobs to realizing that maybe, just maybe, they could be the ultimate coworkers. So everyone listening, hold off on those robots took my job headlines for now. But it does make you wonder what happens next. What's next for AI and its role in, not just machine learning, but everything? It really does feel like we're just at the tip of the iceberg here, right? Like this research is just a tiny glimpse into what AI might be able to do, a few years, maybe even a few months from now. Who knows?
Yeah, it's moving so fast, it's kind of hard to keep up. But one thing that researchers are really focused on right now is making AI more efficient. We talked about how just throwing more computing power at their problem didn't magically make the AI better, right?
Right, like bigger isn't always better.
Exactly. So there's this big push to find ways to make AI less resource intensive. Smarter algorithms, more efficient hardware, the whole nine yards, even how much energy they use. which is a whole other can of worms.
So it's not just about making AI more powerful, it's about making it more sustainable too, which honestly, that's something we should all be thinking about.
Absolutely. And beyond just efficiency, researchers are also working on some of those limitations we talked about. Making AI better at handling really complex debugging, being more adaptable, having more of that critical thinking ability that we usually think of as like a uniquely human thing.
So teaching AI to think less like a machine and more like, well, more like us. That's a pretty ambitious goal, don't you think?
It is. It's hugely ambitious. But if they can crack that code, I mean, just imagine the possibilities. We could have AI designing and building even better AI
Hmm.
and doing it with a level of like creativity and problem solving that rivals our own.
It's funny, a few years ago, the idea of AI exceeding human capabilities was kind of terrifying. But now it feels more like we're working with AI, trying to figure out how to use its strengths to solve problems we could never solve on our own. This whole conversation has been a wild ride, honestly. We went from AI playing chess to AI potentially revolutionizing every industry on the planet. It's crazy. And it all begs the question, what does this mean for us? What does it mean for the future of work, for the future of, well, everything, really? If AI can do all this stuff and do it on its own, it's a lot to
It
process.
really is. And it's not a question with an easy answer. It's bigger than just jobs, right? It's about our place in the world, our role in a future where AI is like everywhere all the time. It's exciting for sure, but it's also a little bit intimidating, right?
Yeah, definitely a little bit of both. And I think what's becoming really clear is that we need to be having some serious conversations about the ethics of all this. We need to make sure that as AI gets more powerful, we're using that power for good. That we're using it to make the world a better place, not accidentally creating a whole bunch of new problems in the process. And these aren't just abstract, hypothetical problems either. It's something we need to be thinking about right now, today.
Couldn't agree more. This research has shown us that AI is developing way faster than a lot of people thought it would. It's a powerful tool, and like any tool, it can be used for good or bad. It all depends on who's holding the hammer, right? It's up to us, all of us, to decide what we want the future to look like, what role we want AI to play in that future.
Well said. So, to everyone listening, we'll leave you with this. The future isn't set in stone. It's something we're all creating every single day through the choices we make, the conversations we have, the actions we take. And that's both an amazing opportunity and a huge responsibility. This has been a really incredible deep dive. Thanks for joining us as we explored the crazy, amazing, and sometimes kind of scary world of AI. Until next time.